Hi, this video is about principle-based thinking, a reason to learn physics even if you aren't going to be a physicist. Now imagine you're spending a day at a relative's house and a younger cousin, a kid cousin, comes up to you and says, I know how to add. And so you say, okay, what's 6 plus 7? And he says, 13. Very good. And then you ask him again, what's 12 plus 13? And he says, 25. Okay. And then you ask him one more, what's 14 plus 2? And he suddenly says, you know what? No one's taught me that yet. And so if you heard this, you might be a little bit perplexed and ask him, have you really learned to add, or did you just memorize a bunch of answers? And this extends to the workplace as well. So even though the example was a bit trivial, rest assured that even on the adult landscape, this continues to happen. For instance, a boss is chewing out an employee and saying, why isn't the new project done yet? And the excuse that the employee might come up with is, I've never solved this before, and no one has showed me how. And you can imagine how such an employee would be a lot less valuable than another employee who takes on new problems and challenges and is able to solve them effectively. There will always be new problems. And so we want to make sure that we can position ourselves and be able to solve these new problems reliably. The idea here is for us to be able to apply what we have learned to new problems. All the principles and all the theories that we learned in our academic journey, hopefully we are able to apply them to when we go out into the working world. There are many ways to achieve this, and one of the ways is to achieve it through principle-based thinking. Now, what is principle-based thinking? I define it as using general relationships between two or more quantities to explain observed phenomena, formulate experiments, or predict future outcomes. It is a pathway to mastery, particularly in the sciences, and it is a problem-solving technique. So what are some principles in physics? Now, once again, a principle is a general relationship between two or more variables. So some principles that should come to mind are Newton's laws of motion, principle of conservation of energy, and by the way, in my opinion, these two principles are the most important for you to know. But there are also the laws of thermodynamics, the principle of superposition, Faraday's laws and Lenz's laws, and in every chapter you can think of others, so the list goes on. And this applies to physics, of course, but it applies to also all the topics you have in economics, chemistry, literature. There are principles to be found everywhere, even in the culinary arts. The power of principle-based thinking would extend beyond academics. So for example, picture you're a manager in a company and you're trying to mediate conflict between two parties. Naturally, there'll always be new conflicts and new people. So quite likely you'll encounter conflicts that you've never managed before. But in order for you to come up with effective solutions, you will fall back on what are good principles of conflict resolution, maybe from the times that you have learned about conflict resolution. One of the principles that might come to mind is, okay, it's better for us to seek to understand the other party first and then to be understood later. And this builds the communication connection. Therefore, what a manager might say is, guys, let's see if we can accurately summarize the other party's concerns first before we continue with the discussion. So what is not principle-based thinking? One type of thinking that I would like to contrast this to is solution-based thinking. Now, how do you tell if someone is doing solution-based thinking? Well, when they're trying to solve problems, they would be asking themselves, have I seen this problem before, and what was its solution? On the other hand, a person who is practicing principle-based thinking would be saying, what principle is applicable to this problem, and how is it applied correctly? So you can see that these two forms of thinking are very different to each other. One of them is trying to recall a solution, whereas the other one is trying to formulate a solution. So for the one who's trying to recall in the solution-based thinking, if he can't recall a solution, then he'll say, oh no, I can't remember, and then he would be unable to solve the problem. However, for someone engaged in principle-based thinking, he would say, let's try a principle. Maybe Newton's third law of motion might be applicable and see where it takes me. And evidently, the one on the right, principle-based thinking, would stand a much higher chance of solving the problem and obtaining a higher level of mastery of physics. So there are many problems associated with solution-based thinking. Firstly, you can't solve new problems because you've not been exposed to the solution. Every question looks different because every question requires a slightly different solution. Problems cannot be solved if the solution is forgotten, so you spend all that time memorizing, but then you go into the exam and you can't recall the solution, and therefore you can't solve the problem. And even if you can recall the solution, but you recall it wrongly, then you solve it wrongly. What causes solution-based thinking? What habits might a person have that would cause this to happen? Well, firstly, a person could be practicing questions without consolidating the chapter's principles. If you do not have the principles in mind, then you do not know when they are being applied. And then all you are doing is memorizing solutions. A person could rely very heavily on solutions as well. For example, the way they study is, okay, I'll look at a problem, I'll look at a solution, understand the solution, and move on. If this sounds familiar, then you might very well be a person doing solution-based thinking. Another one is if a person was to say, oh, so if I see this problem, then I will write this. And this kind of see a problem and respond and react type thinking is not really helpful in achieving topic mastery. Finally, a person who is simply engaged in memorizing solutions to each problem. Evidently a very painful way to study and one that honestly does not yield much results. So this might sound familiar. And if it does, you might just be the type of student who puts in many hours of practice, studies very hard, but does not achieve the results that are appropriate to your efforts. Now, let's talk about the benefits of principle-based thinking instead. Now, when you're engaged in principle-based thinking, questions solved with the same principle look the same. It doesn't matter if it's a bird, a truck, a boat, a spaceship, but if you're always using Newton's second law of motion to solve these problems, then all these problems would actually look quite similar, and you're able to group them in the same family of problems. It helps you to acquire principle mastery, and therefore you are able to solve questions never seen before. If you are really good with, say, the laws of thermodynamics, then if I were to set a question that is on the laws of thermodynamics that is brand new and no one has ever seen before, you would definitely stand a much higher chance of solving that problem given your mastery of the principle and your ability to apply it correctly. Finally, it gives you topic mastery. You are able to differentiate principles from its applications because you are very strongly engaged in seeing how principles are applied. And so you are able to master a topic very well because you can differentiate its core principles and the applications. So how does one achieve principle-based thinking? I'll outline some strategies and then go through each of them in detail. 1, you want to be writing really good summaries. 2, as you write your summaries, acknowledge each principle's problem-solving ability. 3, write principles in its raw form as you use them. And number 4, when checking solutions, which is fine, but when you check solutions to the questions that you practice, it is really important that you look at the principle application rather than the final answer. So let's go through these in turn. Writing good summaries. Now, here's an example of a summary that I really like, where a student captures the central ideas and central equations to a topic. And thereafter, there are 2 to 3, maybe even 4 examples that really help the student to capture their learning and form a foundation of application of the principles. Another strategy to achieve principle-based thinking is to acknowledge each principle's problem-solving ability. For instance, when writing summaries, and a summary that you would be writing is on forces, where you would be consolidating the principle of moments. So for instance, you write down the principle of moments for an object to be in rotational equilibrium. The sum of clockwise moments about any point must equal the sum of anti-clockwise moments about that same point. In addition to this, what you might want to do is to write about the problem-solving ability of the principle of moments. For example, to determine if a system is in rotational equilibrium, or to determine the magnitude of a force based on turning effects. Now, there are many ways for you to write these 2 bullet points, and there's no hard and fast way. But the idea here is for you to know its problem-solving ability, so that when you encounter problems and based on the task at hand, it gives you a faster signal of which principle to employ to solve the problem. Another strategy to achieve principle-based thinking is to write the principle in its raw form before it is used. And it's also, in my opinion, that this is the most important and powerful way for you to practice principle-based thinking, which is through your writing. I believe that when you write a certain way, it causes you to think a certain way. And when you think a certain way, it causes you to write a certain way. And it's a feedback loop. It's a feedback loop that you really want to reinforce. So say you're solving a question and the question involves the principle of conservation of energy. What you want to do is you want to write it out. And of course, write it out in its raw form in the equation form. So here you can have the sum of initial energy equals the sum of final energy, which is really the principle of conservation of energy in equation form. And then from there, you contextualize it to whatever the problem is being solved. So in this case, it's probably something to do with gravitational potential energy being converted into kinetic energy and heat generated. So on the left-hand side, you have initial gravitational potential energy. And on the right-hand side, you have the final gravitational potential energy with kinetic energy and heat generated. So regardless of what the context is, you really want to write your working something like this, starting off with the principle in its raw form, and then you contextualize it. After that, you proceed to solve. So it looks like this question involves solving for the heat generated, and you form the right-hand side, and then you proceed with the substitutions and the final answer, which really isn't the focus. I hope you understand by now. The focus really is the principle application. So a strong student would really focus on what principle was used and how it was applied correctly. On the other hand, a weak student would really just focus on, all right, what's the substitutions? What's the string of numbers I need to write? And then what's the final answer? So if you have the habit of just writing numbers and the final answer, then it might be quite likely that you are engaged in solution-based thinking. However, if you make it a habit of always writing whichever principle you're using in its raw form, you are going to be much stronger because you are practicing principle-based thinking. Another strategy is when you inevitably check the solutions of your answers, that your priority is to check the principle application. What does this mean? So for instance, here is a typical solution that you might encounter in, say, your tenure series. You see in the way that it's written out. Well, evidently it's not written, you don't see the principle written explicitly here. However, what you want to do as you are writing this is to acknowledge that the principle of conservation of linear momentum was applied in this case. And for any other solution that you encounter, that you explicitly acknowledge what was the principle and perhaps even write it down next to the solution. In summary, 4 strategies have been outlined to you to achieve principle-based thinking. Writing good summaries, acknowledging each principle's problem-solving ability, writing the principle in its raw form before it is used, and when checking solutions, the principle application is the priority. Thank you for your attention, and I look forward to having principle-based discussions with all of you.